welcome to November 1st. This is the meeting for FPGA. We call it our stand-up because we talk about what we've done over the past week, what we plan to do over the next week, if we have any roadblocks, and if we need any resources. And let's start off with James in Remote Lab South.
Not too much to report here in Remote Lab South. We're just getting more work done. Later this week, we'll be getting rid of some items that we've been trying to get out of one of the primary outbuildings. So we'll be having a better way of disposing of some of the material we're getting rid of. But otherwise, not too much else to report here from Remote Lab South.
Okay, so you're not ready to receive the equipment?
Not yet, but we should hopefully be so soon.
Okay, good. Do you need any resources? Anything needed to move forward?
Nothing in particular. The main resources that we're looking forward to are the ones that you're planning on shipping us. But just for our current needs, we're doing fairly well.
Okay, thank you. Sounds good. How about you, Paul?
Hello. From Remote Lab West, there's nothing much to report. Things have been working. We've been using it extensively for working on the FPGA. I'll leave you to cover the details on that. I've been in the background helping out here and there, rubber ducking. But otherwise, it's been you.
Well, me and a pile of other people's work. So thank you to everybody that's produced all of this great work and given good advice. So yeah, I can show probably the best visual that we have for this past week is that we finally found some documentation for the problems that we've been having, and it's I guess kind of our own fault for not knowing that this existed on the Analog Devices website, but I'm going to show you what we know to be true now, but through the miracle of sharing screens. Okay, here we go. All right, share. So this drawing sums up the challenge that we have been we have with the encoder from Swato and Anshul and all the other people that have contributed to it. So what we're doing is a DVB S2 and eventually S2X encoder in hardware, FPGA, for the our first target, successful target was the Pluto, which is a 9361 device. The ZC706 has a ADRV 9371 on it. And one of the big differences is that 9371 has a JESD204B interface and some other big steps forward. It's a great part, but it's complicated. And the unpack, which is after the DAC FIFO, does this job. So we have 128 bits on the left coming from the DAC FIFO, and that goes through and is divided up in the following ways. This is 2 channels enabled, so this is going to be a transmitter 0 and transmitter 1. So that's how it goes. That's how we thought it went. Now we actually have confirmation and attempts to get the bus correctly sized up, our 32 bits of output sized up correctly to the 128 bits. I think we're much closer to seeing that done. The AXI Smart Connect thing that I tried to do was not the right thing. Plenty of us have learned a lot more about AXI and various types of interconnect. That's the good news. And the bad news is that we thought it would work. Probably the best and most most positive thing that we can do at this point is to go ahead and finish the part that's in FPGA cores from Andre Swato's work. So he has a bus resizer that we're using to go from 32 bits from DMA down to 8 bits for the encoder. So that is it's in the wrapper, and it's in the design. Now that same entity, looks at is the bus larger coming in and smaller going out, and it handles that, and it looks at equal bus sizes and just passes it. The third case is not completed in this particular entity, and that's the case that we need, where it goes from something like 32 bits up to 128. So that'd be kind of the perfect part. Um, there also are a couple of existing designs on GitHub that do this sort of serial to parallel, parallel to serial for AXI bus. But since we have a design that we're already using, it's already a submodule, it's already in there, I think completing that might be the thing. Okay, so I'm going to stop sharing that. I just wanted to show everybody that this is what we're after, and it should work. The other things that we did this past week, hello, hi Sasha, and hello Everest. Thank you so much. The other thing that we were able to do this week is that we I think we followed Sasha's advice. Like, you go back to the regular design, the reference design, and do more things with that. And so what we've done right now in the lab, the reference design without the encoder in it is what's the bit stream that's on the ZC706 and 9371, and we're able to control it with MATLAB. Now, this was kind of an adventure. The Hello World from MATLAB from the transceiver toolbox did not work out of the box. And it didn't work for an interesting reason. The sample rate is 122 megahertz, or 122.88 megahertz. And if you don't actually get that from the encoder object that you make in the system object that you make in MATLAB and then use it, nothing works. It acts deranged. It was the most remarkable set of signals, and it made us feel really dumb because hello world not working. But once you find in the 3 different places that you have to go on the MATLAB website, once you find out how to use the transceiver toolbox, then it starts to make lots of sense. So we were able to move all around and set up simple signals with doing it this way. Another advantage to MATLAB is that the transceiver profiles, which are very important for analog devices, transceivers, those receiver or transceiver profiles are very easy to experiment with if you run it in MATLAB. Eventually, we will most likely have to set up our own custom transceiver profile. I think that's almost a sure thing. And when you do that, it's actually part, I believe, of the DTS file. So what you're doing is you're making it part of the design all the way back to that level. And we'll need to do some experimentation and to figure out all the different, changes to clocks, changes to filters. Those are things that we might need to do. The default profile that we use right now is fine for now. So it won't prevent us from moving forward or anything like that. But in order to optimize the design later on, the ability to experiment and update profiles, we'll need to know all that. So we also rebuilt the integration, the database, or the repository that we use with the encoder integrated. I went ahead and just deleted the one that has the clock errors, or didn't delete it, set it aside, and then redid it. I did not get a chance to test it before this meeting today. So that's the rest of the day going to be working on that. I'm suspecting that the clock errors might go away because it could be that we managed to corrupt the project. It occurred to me that might be the thing. And we also invested some time learning how to use ILA, the integrated logic analyzer functions in Vivado. This is very different than the old debug cores that I know how to use. There's lots of improvements, and it looks like it might be the thing. And I know that Anshul already knows how to use these. I believe Everest probably does too. So we just spent more time trying to catch up to where you all are. So I think that that hits all the points that I wanted to hit, and I'll turn it over to Everest.
Yeah, I don't know if it's working. Let me know. Sorry, I don't know if it is working right now.
Yeah, I can hear you.
Okay. Okay. So sorry, I was in holiday, so I just follow message on Slack, but can't contribute. Yeah, so there is some clock error. As I said, there is 2 different clocks. Well, I mainly speak about the Pluto design. There is one clock for the CPU, which is the clock for the DMA, and there is another clock for the DAC. And there is a component in between which is a FIFO, which transfer one clock to try to convert one clock to the other. I have to see more deep on the this is 706 design. But yeah, we have to investigate on that. About the UPAC, I think that's, well, on the Pluto design, in order to have no issue, I have only one channel, which means that the UPAC allows to multiplex the 2 channels. And if we need only 1 TX right now, well, firstly, on the easy way is to have only 1 channels. So enable only 1 channel, and then we avoid some problem. And after that, maybe if we want the 2 channels, then use more channels. But that's another way. The main issue right now is not, well, it could have some issue with IQ right now on the UPAC, but the main issue right now is that we need to have the right order of byte. I need to leave. The right is to have, yeah, the right byte on the encoder. I need to leave, sorry, because the child call.
No problem. Thank you so much, Évariste, and see you soon.
Yeah.
All right, that's good advice. I'm looking forward to this next week. All right, Sasha, hey. How can we help?
Hey, does my audio work?
Yeah, I think so.
Okay, cool. So I actually was wondering, for the IQ modulation, so taking IQ samples and converting them to some flavor of analog, it seems like the 80, I think 9371 or 9361 or whatever that part, it doesn't seem to be available on DigiKey. And I'm wondering, do you have for the flight hardware, do y'all have like some of those like stocked up, or is there the possibility that we might need to, for flight hardware, use a different way of converting IQ samples into some flavor of analog RF or IF or something like that?
That's a really good question. I think that's probably a question for Thomas Perry to answer. And my opinion and focus right now is to get it working on the development stations that we have, and the original path was through 9371 to flight hardware. So I'll try to get a better answer if we can get it working with the Xilinx and analog devices combination. Then I think that's what we move forward with to try to get towards flight hardware. But the final decision will be one that like Thomas Perry and Jan King will have more of an opinion on. And
Okay.
I talked to Jan King today. So we have a meeting set up in about 6 hours or so.
Okay. Would it be okay if can we chat afterwards on Slack about some slight hardware questions.
Yeah, sure.
Because-
Yeah, sure.
Because if there's, because it, like, yeah, I'm wondering like who's going to, if we can't find an 809371.
Yeah,
Yeah,
parts
are
are
we
going to
gonna
be
do?
hard.
Be hard.
So, because
I mean, I'm sure you've seen the problem with all sorts of supply chain
Yeah,
issues
I
and
have,
challenges, and yeah, we're going to have to deal with that.
okay. So I might actually, I'm gonna try and get started. I've got my workstation almost set up. I moved recently, so I'm gonna try and get started with just the up conversion, but I'm also gonna try and take a look at different ways to do DAC and IQ modulation and stuff like that, because I think there's alternate parts.
Thank you. That would be
Thank you. That would
super
be
helpful.
super helpful.
Okay, cool. So that's what I'm gonna try and, that's what I'm gonna try and get started this week, and I'll try and post my work in progress in Slack.
Very good. Evereast says, sorry, there was a monster in the house in chat. I have 3 monsters here. I understand. All right. Any questions or comments or any other input for our meeting today? We've got plenty to do. I have a quick question for James. James, have you been able to look at all at the agriculture department section of grants.gov for anything that might work for the remote lab?
I haven't found anything that really stands out to me as something that we really want to pursue. A lot of them have been for things that aren't quite within our interest, sadly. But I
Okay.
have been looking through some of that list.
Yeah, just keep an eye on it. I think that the grants come out in batches. I'm a little more familiar with the digital communication side than like the agriculture, but yeah, just keep checking in, and as soon as you see something, then raise it on remote labs, and we'll tackle it. I think we looked at we looked and wrote just for everybody else to catch up with the remote lab. This is a microbiology and bacteriophage work. So we tried to do this through some what looked like some promising FDA paths. But since it's R&D for bacteriophage work for fish farms, probably Department of Agriculture might be a better fit. So we're keeping our eyes open for that for this particular remote lab. Cool. So thank you so much to everybody. See you on Slack, and let me know if you need anything. We're moving forward on a bunch of different things. It's complicated and ambitious work. Your time is deeply appreciated, and see you next week.